Okay, the answer for this one is B. Now I'll just see if I can explain why. Okay, so the answer is B. Alright, let's think about this. If a ball's thrown upward at an angle of 45 and it landed at the same height as thrown, basically the situation I've got for this is this. I'll just draw it down here. Okay, it's projectile motion. Throw it at 45. So we've got a projectile that does this. Now if you think about it, the sideways or horizontal velocity, okay, is constant. So the kinetic energy for the horizontal motion is constant. So if you were to graph that, it would just be a straight line straight across. Okay, so the thing that's changing the kinetic energy here is the vertical motion. Okay, so if you think about it, tossing a ball at 45 degrees like this, we can actually model the horizontal motion as the ball just going up, stopping, and then coming down and accelerating on the way down. So I'll just do that up, it'll go up, slow down, stop, and then come down and accelerate on the way down. So if you think about it, on the way up, its kinetic energy is being lost, okay? So on the way up, kinetic energy is being lost, so kinetic energy is being lost. So if you notice, the kinetic energy is being lost, okay? And then it reaches a minimum kinetic energy, okay? And then the kinetic energy increases, okay? So kinetic energy goes down as it gets higher, and then on the way down, the kinetic energy increases, okay? As you go down, the kinetic energy increases, okay? So that shows here as you go down, the kinetic energy increases. Now the thing you might ask though is that, why doesn't this actually hit 0, okay? So a lot of people that year actually picked C as the answer, and that's wrong, and I'll tell you why. Because the ball has sideways motion or horizontal motion as well, its kinetic energy is never 0. So whilst the vertical motion goes up, stops, and comes back down, so the vertical motion goes up, it stops there, the ball doesn't actually stop there. The whole time, during every point in that flight, there's a baseline kinetic energy, which is the horizontal kinetic energy, because it's always moving sideways. However, the kinetic energy in the up and down component of the motion, on the way up the kinetic energy decreases and then it increases on the way down. Okay, so the answer must be B. Okay, if you've got any more questions about this, please message back and let me know.